In this segment, we're going to look at another important programming concept, and it is the logical operators. All modern languages have similar acting logical operators, and we'll, of course, be looking at the logical operators as they exist in the C language. There are three logical operators, and they correspond to the English words and, or, and not. We use these words all the time. They're very common English words, and sometimes we use them logically correct and sometimes we don't. Let's look at these examples. I'll eat lunch if it's noon and I'm hungry is different from I'll eat lunch if it's noon or I'm hungry. And you see that in the first one, I'm less likely to get something to eat than in the second one. If one or the other condition is true, where or is the key word there, then I would get to eat lunch in the second one. But in the first one, both of the conditions would have to be true in order for me to get to have lunch. So and or, we use them in English, but we don't always get them right. One more example before we leave that. I was in a meeting where the presenter said, everyone stand up if you were born if you were born before 1960 and after 1990. So the presenter wanted the older people and the younger people in the room to stand up. And there was logically no one could be born before 1960 and after 1990. So we use these logical words in English and everyone knows what we mean, but in a formal logical sense, we're going to have to be very careful that we're saying the words that we need. Okay, let's look at the logical operators in C. We don't write the words and, or, and not in C. We're going to write these symbols. 2 ampersands together is the logical and these 2 vertical bars are the or, and that vertical bar on your keyboard is shift backslash, so it's the one just below the backspace key. On the keyboard it looks like 2 little dashes, but when you type it actually is just 1. And the not operator is going to be the exclamation point in the C language. So here's a way of using logical operators to make a more interesting condition for if statements and while loops and so on. So look at this condition. If A is greater than B and C is equal to 10. So when would that condition evaluate to true? Well, because it's the logical and, that would be true if A is greater than B and C is equal to 10. So both of them would have to be true for that condition to evaluate to true and then go into the body of the if statement. Logical operators work with true and false values. So the operands of and are, in this example, A is greater than B. That evaluates to true or false. C is equal to 10. That evaluates to true or false. And then we and together those logical values, or those Boolean values. A Boolean value is a value that is true or false. That's all there is in formal logic, is true and false. Okay, let's go and look at what are called the truth tables for the logical operators and, or, and not. The easiest one is not. Let's look at it. It's on the right here. What's not true? False. What's not false? True. So that truth table is very small. Notice that the not operator has only one operand. So exclamation point and then something on the right. Not true, false. Only one operand, while the other 2 have a left and a right operand. So the and truth table is at the top of the slide, true and true. So if we're evaluating a condition where the left and the right operands are true, and we and those together, then the result is true. With the and operator, In all other cases, it evaluates to false. So with and, both of them must be true in order for the result to be true. With or, the table at the bottom left here, true or true is true. True or false is true. Only one of them has to be true in order for the result to be true. So in all cases except one, we have the resultant value true, and that's when both of them are false. So one of them must be true when we're ORing them together in order to get a result of true. When we use more than one logical operator in an expression, there are rules of precedence, the same as we looked at rules of precedence for multiply and add. So multiply happens first if there are no parentheses to otherwise say that the add should happen first. So the rules of precedence in logic, logical operators, the unary operator, which in our case here is the not operator, happens first. And then the and will happen before the or if they both appear in one expression. And this is a sticking point for a lot of people. And happens first before or. So here's the example. We have A is greater than B, or C is equal to D, and A is less than D. I don't know what these A, B, C, and D variables mean. We're just using those for the purpose of looking at the logic in these expressions. So in this case, we would do the relationals first. We're going to read this slide from that expression starting A is greater than B. We'll read it down and look at how to evaluate the expression. We'll do the relationals first. So suppose A is greater than B evaluated to true. C is equal to D evaluates to false, and A is less than D evaluates to false. So now we have true, or, false, and false. It's important that we do the and first. So we have false and false, and that evaluates to false. And then we have true or false, and that evaluates to true. If you try this one doing the or before the and, if you evaluate them left to right, you'll get the wrong answer. This is kind of a tricky problem because most of the values of true and false you'll get the same answer. This is one of the few examples where you'll get the wrong answer if you don't know that the and happens before the or when they both appear in an expression. Let's look at true and false in the C language. A lot of modern languages have a data type for Boolean. So in Java, for example, it's called Boolean, and in C# it's called bool. In C, which is an older language written originally in 1972, we don't have a data type just for storing the values true and false. So in C, we use numerical values for true and false. So 0 is considered to be false, and non-zero is considered to be true. So that allows some things to be written in C that don't really make sense. For example, if 15, that as an if statement wouldn't make sense to me, but in C it does make sense because 15 is a non-zero value, and that would evaluate to true. So that if statement would say the flow of control goes inside of the if because 15 is not a 0. Okay, this is a little bit of a tricky point in C. When you have when C evaluates a relational operator and it decides true or false, it will evaluate to 0 or 1. For example, if we said if 10 is greater than 5, what does the 10 greater than 5 evaluate to? Well, we've been saying, up until now, we've just been saying 10 is greater than 5, that's true. And what actually happens internally is it evaluates to 1. 10 is less than 5 evaluates to 0. So when C gets to decide which non-zero value it will use, it uses 1 for true. If you use a non-zero value, you can use any of them, any non-zero value for true, and 0 for false. Okay, let's look at some logical expressions that you're going to be asked to evaluate now. We have 3 variables, a, b, and c, and we put values in them 10, 6, and 4. Now suppose we had these if statements. If a is less than or equal to b, or c is greater than or equal to 4. Is that true or false? Well, I've got the answer on that one. A has 10, b has 6. 10 is less than or equal to 6. That part's false. So we go over to the right-hand side. C is greater than or equal to 4. C is equal to 4. So that side is true. We have there false or true. And it evaluates to true. If you need to, go back and look at the truth table for or. If either of them are true, then it will evaluate to true. There are a few more for you to evaluate, and if you want to pause while you do that, I'll show you the answers. They're on the next slide. Did you pause? I'll show you the answers. Here they are. If you can do those, including the not operator, should have gotten these answers. And we're not going to go into the development environment, but if you would like to, go into the development environment and actually execute some of these and make sure that it's making sense to you that these evaluate to the true and false values that you expect. A couple of pitfalls here. When we first started out in this, I said, here's the assignment operator. It's a single equal sign, and you should pronounce it gets. So if you say A gets 10, as opposed to saying A equals 10, then here's the problem that you won't encounter. When you're writing an if statement and you express an equal sign and accidentally type an assignment operator, so in this one you should be reading it A gets B. If you're reading it A equals B, then what will happen? It will evaluate the assignment operator and treat it as a Boolean value, a true or false value. Well, what does the assignment statement evaluate to? In this case, we had A and B. A has 10 and B has 6. In an assignment statement, the 6 will go into the variable A. The assignment operator in C evaluates to the value that goes across the assignment. So in this case, A gets B evaluates to 6, the value that was in B and went into the variable A. So when you reduce that, we have if 6, which is true. If you're reading that if 10 is equal to 6, you would want the answer to be false. It would be nice if the C compiler would not compile this, if they would recognize that you really intended to express the logical operator equals, which is 2 equal signs. The relational operator equals, which is 2 equal signs, but accidentally typed the assignment operator. If it would not compile and tell you you did that by mistake, that would be a good thing, but that's not what it does. 10, A gets B, in this case evaluates to true, but A equals B would not evaluate to true. Here's another pitfall below the line on this slide. The not operator happens before the relational operators. So in this case, we have another one of these problems with C treating logical Boolean values as numbers. So if you wanted to write if not A is less than B, and you write it the way it is here at the top, not A would happen first. If A has 10 in it, what is not 10? 10 is considered to be true. What is not true? False, which is 0. So the way this is written, if not A is less than B, is probably not what the programmer had intended. The programmer had intended to evaluate A is less than B, and then invert the logical result with the not. So the parentheses are almost always used with the not operator, and it's written there at the bottom. Not parentheses A is less than B. This is also a tricky problem because most of the time you get the same answer. And in this case you would. Not 10 is 0. 0 is less than 6 is true. And if you do it the reasonable way, do the relational operator first, we have 10 is less than 6. That's false. Not false is true. So you get the same answer but for the wrong reason. Tricky problem in C. Here are some for you to practice. And that first one has an arithmetic operator in with it. That's the first time we've seen that. Mixing arithmetic operators with relational operators. So we have A is less than or equal to B plus 1. Which do you think should happen first? The less than or equal to relational operator or the arithmetic operator? And if you mix these, the arithmetics happen first. If you said A is less than or equal to B, what would you then do with the plus 1? So for most people, this just makes sense. You don't have to memorize a rule of precedence between the arithmetic operators and the relationals. It just kind of makes sense to most people that you would do the arithmetic operators first and then use the resulting values to evaluate the relational operators. What I encourage you to do is to take these ones into the development environment and evaluate them. It will give you good practice to type the relational operators and make sure that they're doing what you expect them to do. One more concept in this segment, and then we'll do a review of the logical operators. This is called the short circuit behavior. So the operators that I showed you for and or, using the 2 ampersands and the 2 vertical bars for and or, there's actually 2 operators for and, the 2 ampersands and 1 ampersand. Similarly for or, there's another operator with 1 vertical bar. Usually you would use the ones that I introduced first, the double ampersand and the double bars. And I'll explain now why there are 2. In this expression, 10 is greater than 20 and A is greater than B. Let's evaluate the left-hand side first. 10 is greater than 20. That's false. And now we have false and anything. It doesn't matter what's on the right, because false on the left of an and means that we know this whole expression will be false. Short circuit behavior means we don't evaluate the right-hand side if we don't have to. When you have a false on the left-hand side of an and, you can short circuit and you save some time. So we have an efficiency issue here. You don't have to evaluate the right-hand side to know that this whole expression will be false. It works just a little bit differently with the or. When do you know that the or is true, or when you know the result of an or? Let's look at this one. 10 is less than 20, or A is greater than B. Well, 10 is less than 20, that's true. true or anything is true. So with an or, we know the result when we have true on the left. And with an and, we know the result when we have a false on the left. And in both of those cases, if we're using the short circuit operator, we won't need to evaluate what's on the right. If you have some reason that you want to evaluate what's on the right, and up until now we haven't looked at any of those cases, then you would want to use the single keystroke operator so that the right-hand side would always be evaluated. Until you get to that, you should use the more efficient short circuit operators, which are the first ones I introduced here with the 2 keystrokes. Quick summary then of what we've looked at in this segment, the 3 logical operators, and, or, and not. And we're talking about formal logic now, not the use of and, or, and not in English, which often is incorrect, but we still know what it means. These logical operators are used to express more interesting conditions in our C program, so that our if statements and our while loops and so on will be more powerful. The precedence order for the logical operators, the not comes first, and then the and then the or. We looked at true and false values in C, and we recognize now that C uses numerics for representing true and false. 0 is false, non-zero is true. And lastly, we looked at the short circuit behavior of the and or operators. If you have false on the left of an and, you can short circuit, you don't need to do the right. And if you have true on the left of an or, you can short circuit and save some computing time. The other operators, which are less commonly used, the single keystroke operators for and or, will evaluate both sides, regardless of how the left-hand side evaluates. That's it for the segment on logical operators. We'll see you next time.